Ah, that one. I don't have glasses. I don't see anything. Okay, put it here probably. My wild one.
It's on the desktop. Yeah, just put it on the desktop somewhere. Yeah, that's yeah.
Yeah, this one
Okay.
might for it.
We will start in the same order like before. We just
Okay, so but I have 1 minute less because
10
don't ask them after.
Yeah, we have to be quick this time because there will be wrap up. Aber hier ist ja, oder? Ja. Ja, aber dann kommen sie alle wieder hier rein, wenn wir dann nicht fertig sind, ist blöd. Also wir müssen diesmal wirklich fertig sein. Ivana or some of the online people, can you hear us? Ivana? Hi, Ivana. Hello, Ivana, can you hear us? Or somebody else, online people? Can you hear us?
Yes, we can hear you. We can hear you, right?
Thank you very much. We can hear you as well. That's great. And now we have to share the screen. So I hope you can see the presentation online. You can hear us. Please, everybody, have a seat. We have to start fast and also finish early because we have 5 minutes less than 1 hour this time. My name is Frank Wenzel. For you that don't know me, I was the coordinator of SAS Food together with Nicola Hassan in SAS Food and Core Organic. When Ivana was here online with us from Core Organic, we had this nice call together. You heard a lot of the projects probably in the first session, so now we have the next 4 projects. It's kind of a German-Italian co-production today because we have 1 German presentator, 3 Italian ones, and a German moderator. I don't know how that happened, but anyway, please, Stefan, tell us more about the food project. I will talk up to you after 10 minutes.
Maybe you do it after 8 minutes, and then I'll make sure I'll be done by 10. So, because I don't know, I'm not sure, I hope you're curious what I'm talking about, because I'm so as well. I prepared this presentation some time ago, and I'm going to report some of the results that we came up in the Foodiverse project. And what I said during the pitch, we took a food systems perspective, and it might seem as a very easy question to think about what is this thing called diversity. I mean, if you are in biodiversity, it's clear to talk about species, it's talking about ecosystems, but what does it mean for the entire food system? And that's a little bit what we try to do in this project, to characterize diversity for the entire food system. And then, of course, we asked ourselves what might be the implications for food systems if they would become more diversified. We know it from biodiversity is positive for ecosystems, but we also know that dietary diversity is good for human health. So there's another kind of diversity which is food related. And we also know that organizations that are diversified in terms of employees, for example, they are also more robust. So there are various kinds of diversity, and we try to make sense or to better understand diversity in food systems at consumer, supply chain, and governance levels. We had partners in the different countries I mentioned during the pitch, and we did. And that was a little bit unique, I think. We used a so-called matrix structure. That is to say, we have 5 different partners. Each partner was responsible for one of these work packages, but we conducted the research in each country. That means each of the 5 partners did research on consumers. Each of the 5 partners did research on supply chains, on governance, and towards the end also implemented living labs. And that is our social science perspective to compare across the different countries, because we wanted to know what role does diversity play, but also how does it roll out in the different countries. At the consumer level, we have analyzed data from a previous project. We have been lucky to have survey data from a previous organic project, and we were able to reanalyze the data through the lens of diversity, which was quite nice, but it didn't really come up with innovative results, for at least not for me. I don't know if you are well aware that those consumers that are interested in more sustainable food, in organic food, they are on average highly educated and with higher income. I mean, it's something that is well known, and it's something that we found in the data. So our data confirmed already what we knew. So we took a second step in the project, and we did in all 5 countries focus group discussions following a specific protocol, which was very interesting to see how diversity is considered on a consumer level in their day-to-day life, in food preparation, in food provisioning. And we're currently analyzing these focus group discussions from the perspective of cultural conventions. How do these cultural conventions in preparing and eating food eventually also consider what's happening on the field? We talk to the consumers and try to understand what drives them to eat more sustainable or more organic food. So even though there are dietary patterns that are different across the countries, but we could see that to some extent consumers are interested in what's happening on the field, but I think on an average level there is less interest on it. What we did for the second work package, we did a market audit, which was a fun activity. We audited these over 2,000 products, saying that we went to the different supply chains in each of the countries. We identified supermarkets, mainstream supermarkets, and more alternative supermarkets, and we were looking at the diversity on the shelves. So we were counting the amount of eggs, the amount of bread, the amount of apples, and it was really nice to see how that how the market is shaped in terms of diversity. And you might be well aware, maybe the lady who is from the Apple project could tell more about it. The varieties that we find in supermarkets is very limited, and there's little biodiversity in terms of apples. What we then also did to supplement that analysis is to look at specific supply chains, short food supply chains, but also in public catering. We did interviews, and a colleague from the UK who was responsible for this work package helped us to better understand the bioeconomic diversity. So what role that diversity might play with regard to agrobiodiversity. And not very surprising, short food supply chains tend to support higher levels of agrobiodiversity because they are more concerned, which is what's happening in the local environment. Because it's also in line with the organizational structure compared to the long food supply chains, long not necessarily in terms of kilometers, but also in terms of the actors that are involved in the food supply chain. And on the other hand, that's something which might work out in public procurement. For example, talking about university canteens. Might have the potential to support agrobiodiversity, but sometimes it really boils down to, and that leads me to the next step, the governance. My favorite example is the potato. If we would like to introduce potatoes in public canteens, we have a problem because potatoes are normally peeled and washed, and canteens don't have the washing facilities, so they are not clean. And then there are clashes with the food safety regulations because you're not allowed to use these potatoes from local farmers. So even if we would like to introduce a more diverse range of potatoes, we would have problems with it. Shortly, the governance, we had a legal scholar involved in it. We looked at the European policies and how they European policies on diversity, agrobiodiversity, but also different kinds of policies that are geared towards diversity. And we tried to look in each country how they are defined. And the example is that my Polish colleague was very impressed how flexible the German interpretation was of the European directives. So there's also room for maneuver on how to implement the European guidelines. And we can see that, of course, there are the European policies and there are trajectories and different stakeholders' perspectives that need to be taken into consideration in case you would like to move forward towards more diverse food systems. And last but not least, we worked with living labs, trying to make sense of the analysis. And the thing that many living labs don't do is to come up with a bottom-up perspective. So we were working with, and that's some of the examples of our diversification roadmap, because we said we need to come up with examples for local initiatives that would like to create more diverse food systems. And we work together with food policy councils, with local cooperatives, with a CSA scheme, and then we try to work out their challenges and problems that might be working towards more diverse food systems. And we have created for each of our 5 living labs these nice figures. This is from Norway, a CSA scheme. And we documented the challenges that we encompassed towards a more diverse food system. You don't have to take a picture, just go to foodiverse.eu and you can download it as a printable version, but there's also more information. There's an interactive diversification roadmap where we try to provide stakeholders with possible ideas. I mean, you can never implement the same strategy that one initiative has to another place, but we thought of giving inspiration to initiatives, trying to help them imagine possible pathways towards more diverse food systems. And there are more examples, but if you have questions, I'm happy to discuss.
Yes, it was perfect in time, so we have time for questions. Yes, there's one already.
Yeah, I'm really interested in the governance dimension. You said that the relationship of each country to the European Union. What do you mean with that?
I mean, when we did the analysis, there was the new framework, agricultural food policy framework. Sorry.
So you mean the CAP, the common?
Yeah, the common agricultural. The CAP, and we were looking at the CAP, and then you have the national strategies on how to implement the CAP.
Oh,
the strategic plans. I mean, we had to rely, I mean, stuff that's out there, so we looked at the strategic plans. But for example, in Germany, you have the federal government, and then you have the Bundesländer governments, and then you still have municipal governments, and they all try to implement various measures towards more diversity, and that there's room for maneuver for all these entities to interpret the CAP, for example, but also the other frameworks, that they play out differently across European countries. And that's, I think, quite interesting. And there's also a paper published by our colleague from Italy on that topic.
And I can't find it in the website, the paper.
Not sure, but if not, I can send it to you.
Because okay, coming from Germany now, it's very interesting because you find more diversity or less diversity in Germany.
How do you define it?
Supermarkets and buying also very limited, limited selection and things like that. So what would you study? Do you find the result that diversity is becoming broader or
no, it doesn't. I mean, it was the starting points to say we have more homogenized food provisioning. If you look at the way that we're eating currently, is quite the opposite from a dietary diversity, and that's also now, as we are finished with the project, I'm a little bit more having a nuanced look at diversity. There might also be downsides of diversity in terms of, I mean, I'm not an economist, so I'm happy to, I'm not interested in the economic benefits. No, I would be rather interested in how to achieve a more sustainable food system, and that is one way. However, there are also downsides, and that's a little bit if you look at the relations of the different actors, you will also see that diversity is not rosy at all. I mean, we might tend to think it's a very nice way to move forward, but there are also some pitfalls and some challenges associated with it. But I wouldn't be able to say, is it more diverse or less diverse? Because my reply would be, it depends. I'm sorry.
Also, like one question behind, so that's an art form, and then we move on to the next.
So I just thank you very much for. And I think I would like to see
If you send me an email, then I can reply to you and I can send it to you. Yeah.
My question. So I was looking at the supply chain. I was wondering, you consider food processors, but they're also very integral actors in food supply chain when we look at culture and the environment that we have in our food systems. You look at the food processors and also looking at supermarkets, was there any form of diversity in terms of the ethos and the values of the supermarket and how it affects the food products that it is on their shelves?
I think at the moment there was little. I mean, we didn't talk to the suppliers because if you look from a food systems perspective, the crucial point are the supermarkets and the buying desks of the supermarkets. So that's what we really like to pinpoint, because that's where the decisions are made. We talked to them, but I think, and probably with organic food, what was similar, that there needs to be more recognition that diversity is an issue, and by doing the research and by talking to them. So the impact might also have been, if we talk to one of the major retailers in Germany, that they start thinking, oh, there is something like diversity that they might have not thought about before. So yeah, but yeah.
Okay, we really have to go on. Please just talk to Stefan later in coffee breakout during the dinner, because otherwise people. Oh no, I killed everything. Otherwise, people will come in and disturb us in our session. So the next project is HO Food. I just learned that it's HO Food. I always thought it's whole food. It's HO Food. So let's put this on. Yes, that's your project. You can call it HO Food. It's fine. Yes, so please. I will interrupt.
Can I put it in?
If you know how to put the full screen, you can do it.
It's in German, so it's a bit more difficult, but no. I have no idea. I don't know.
But I don't know with PS because I'm in. This is folded mode. This is one. It's folded. No.
Oh, no.
Yeah.
It's the other one. It's the last one. Yes, that's the one.
Okay, thank you. Okay, good afternoon again, everybody, and thank you for the introduction and thank you for being here in this session. So I'm really happy to present to you what we've done in these 3 years of the HO Food project on behalf of the whole consortium. So as I introduced during the pitch, the HO Food project is focused on an innovative high-pressure treatment to increase the preservation and the safety of fresh-cut organic food products. So my aim today will be to not bore you too much with a lot of data and results, but to guide you into the rationale of the project. So to show you our solution and the process itself, the objectives and our partners, and then some small pills about the results we achieved and the impacts and our future direction for the future. So let's start from why did we start the HO Food project? So you all know that organic products are well recognized for their high nutritional value and good taste, and also for their environmental benefits. So they have a higher consumer attractiveness, but they often faces some major challenges, which are principally connected with the safety and the shelf life, principally due to the limited amount of pesticides and the preservatives that are used they are affected by a higher contamination by pathogenic bacteria like E. coli or Listeria, then they usually have a short shelf life. So this could hinder their marketability. And as I told you before, there are limited technologies to increase the preservation and increase their safety. So this is also strongly connected to the food waste problem, with nearly 1/3 of food production in the world going to waste. There is a need for new processes to increase the preservation and the safety of these products without compromising their nutritional quality, the visual appearance, and so in order to give to consumer the products with a higher quality as possible. So I present here our solution. We work with a CO2-based process. In particular, we work with high pressure processes using carbon dioxide. Carbon dioxide at high pressure has been studied for many years, thanks to its ability to inactivate a big range of microorganisms and enzymes. But this process was never applied to industrial level due to some industrialization barriers. So with this novel approach, we combine high pressure with modified atmosphere packaging in order to increase the preservation and the safety of these products without compromising their quality, thanks to the low temperature that are used. So looking closer to the process, the fresh cut products are firstly packed in a modified atmosphere with a high concentration of CO2. Then they are pressurized from they're pressurized in a high pressure plant, and the CO2 inside the packaging reach a dense state. In this state, it is able to inactivate microorganisms and enzymes, and we're working at low temperature, so we're not affecting the visual aspect and the nutritional quality of our products. Being the products already packed before the process, after the process, the products have no risk of post-process contamination. And the modified atmosphere also further extend the shelf life by limiting oxidative reaction and the microbial growth. So in order to, so the objectives of the HO4 project was to optimize this novel process on different target products, and also to evaluate the effects of the products, the effect of the process on the microbial safety and the quality of these products, and also to demonstrate the scalability of this process also in comparison with traditional treatments, and also to evaluate the sustainability from both an environmental point of view and economical point of view of this process. We did this thanks to some well-recognized institutions around Europe and North Africa, mainly the University of Padua acting as coordinators and working on the process optimization, on the plant construction and the sustainability studies. Then the Council for Agricultural Research and Economics in Sicily, in Italy, working on the nutritional quality of the products. The Institute of Agriculture and Food Biotechnology in Poland, working on the enzymatic activity and sensorial acceptance. The Ataturk Research Institute in Turkey, working on the bioaccessibility of the products. And finally, the University of Oran in Algeria for the microbiological safety studies. So going into the results of the project, as I told you before, the aim was also to demonstrate the scalability of this process. So our aim was to develop different equipment on different scales, from small laboratory scale to a semi-industrial level. The aim was to develop equipment that were easily scalable, really easy to use. So also, for instance, with quick loading and unloading procedure, to have some models that were able to work in real life scenarios. As you can see here in this picture, we developed different plants, from a 4-liter plant to a 9-liter plant that can be used in different scenarios, for instance, in small and medium enterprises. Then, together with all the partners, one of the objectives was to select the target products for the project. We considered different selection criteria, principally the market potential and difficulty of preservation of these products. and in order to select 3 target products among 3 different classes: fruits, vegetables, and seeds. So during these years, we tested more than 80 products to ensure that these products were able to resist to high pressure, because we're working with a high pressure process. And after a careful consideration, we selected 3 products. Were squash, melon, and almonds, on which we continued with the test during the project. So then on the first part of the project was really important to optimize the process conditions. We talked, for instance, about temperature, pressure, and time, and we optimized this condition based on different criteria. The first one was to evaluate how this condition affected the visual appearance and so the aspect of our products. So, for instance, we considered the color, so an important feature for consumer acceptance. And thanks to a design of experiment approach, we evaluated how this process condition affect the final product. The process optimization also involved the microbiological safety studies. We studied how the different process conditions affect the inactivation of the natural flora of our products, but also some key pathogenic bacteria that were inoculated on the surface of our products. So we optimize these conditions to, for instance, completely inactivate these key pathogenic bacteria while still ensuring a good visual appearance of the products. So after we optimized the process condition for our 3 target products, we studied the quality and the microbial safety of our products during their shelf life. So we studied the products from a chemical-physical characteristics point of view, microbiological safety, enzymatic activity, antioxidant nutritional quality, bioaccessibility, and sensor evaluation. This was done for all the 3 target products for 2 different gas to product ratio inside the packaging. And we compared these results with the same products that were traditionally packed in a modified atmosphere, in air or in CO2. Only to give you some examples of the results, are reported here some example of one of the product, namely the squash, and comparing the mesophilic flora of our products. You can see how the green bars, which is the treated products, showed a much lower microbial contamination during the shelf life, so proving the possibility to increase the shelf life of our fresh cut products. Also here we have the comparison of the 3 products in terms of the enzymatic activity, in particular our 2 spoilage enzymes, so the polyphenol oxidase and the phenol oxidase. And also in this case, the value for the treated products were much lower with respect to the controls. Okay, I'm so late, sorry. Okay, so to summarize the results, we demonstrated that with this product process, we are able to increase the shelf life and the safety of our products without significantly affecting the sensorial characteristics of our products and the nutritional values and bioaccessibility of our products. However, we demonstrated that there's also a strong matrix dependence of the process performance. So each time we need to optimize the process condition for each product. And in some cases, the low amount of CO2 present in the packaging could limit the process performance. And we also evaluated the environmental, the economical impact of the process that were quite low compared to the whole production chain. Really quickly about the impacts of the project. Of course, it allowed us to consolidate the consortium and the various collaborations with the different partners. Also thanks to all the senior and junior researchers and professors involved. We were also able to disseminate our results thanks to numerous publications and participation in conferences and sector exhibitions. And the potentiality of the patent were also demonstrated by other achievements. For instance, we were selected as finalists for the Italian Intellectual Property Award at the Emerging Technology Competition, and also for the Open Innovation Program by Plug and Play. And in the last year, we've also been financed with a proof of concept project by the Italian Ministry of Enterprises. And of course, really importantly for us, we continuously collaborate with company to scale up our products and to demonstrate the feasibility of this process to different products. So really quickly for the future, sorry, Frank. we are continuously improving our process with different strategies, and we are aiming to improve the performance by also upgrading the patent or filing a new one. And of course, now we're looking for new funding opportunities to go on with our research. So thank you very much. These are our contacts and our link to our pages, and I'll be happy to answer to you curiosities or questions. Sorry.
Yes. 2 minutes for questions. One, two, and what does it mean, extended shelf life?
So it really depends on the kind of what we're considering. So in this case, I show the results of the microbial shelf life. So you can see how, for instance, the squash was less contaminated during the shelf life, but then it's quite difficult to say like a specific increase in the shelf life because it really depends on the product.
Days or months?
No, it's still, in the case of fresh cut products, we're still talking about days. Yeah.
But you're not running into the same problem like when they did extended the shelf life of tomatoes in the US.
Yes, sorry, can you repeat?
In the US, they actually also extended the shelf life of tomatoes.
Yeah.
And the consumer tells you, so I don't want to buy old stuff.
That's a good point, actually. I think it really depends on the products, and I think that still, if we're able to increase the final date of consuming the products without adding something that can be like it could be considered as dangerous by the consumer, but actually it's not.
No, it's dangerous. Questions. That's the point. Because the consumer, you harvest it, bring it to the supermarket, you buy it. But your stuff, so standing there on the shelf for days, and the consumer looks at that and says, "Oh no, I don't want this old stuff."
Well, if I consider how I do groceries, I don't think I never seen when the product has been produced, but only seeing when it's the expiring date. So if the actual appearance of the product is good and I see that I'm before the expiring date, I actually don't care when it's been produced or not. But maybe it's my consideration. It could be not for everyone.
Okay, the second question is that.
Yeah, so I think you answered the question now during the discussion. My question was, is it cut vegetables? You showed
Yeah.
the one with the sweet melon, isn't it?
Yeah, yeah.
Was it squash or something? So yeah, I can understand. So your treatment, so you would take a butternut and you would slice it, and some would just don't go through your treatment, and others would.
Yeah.
So it was the same pumpkin.
Yes.
Treated by the same.
Yeah, of course. Yeah.
So I can understand that from a cut, once something is cut, you actually introduce surfaces for bacterial contamination. But how do you understand it with the what did you have? Nuts?
Almonds. Yeah.
Almonds. Is almonds such a shelf life? Is shelf life quite a problem?
Yeah. As I was saying before, for every product we need to do different consideration. For instance, for almonds, we considered more a safety issue, so maybe contamination. So we're not only extending the shelf life, but also increasing the possible contaminants that could be in the products at the beginning. So all the products have a different story, we can say that. So as I was saying, the process is not effective in all the products. Every product needs to be studied for itself. The process needs to be optimized. The results on almonds were the less promising among the 3 products, while squash and melons have the most promising results. But regarding the inactivation of pathogenic bacteria, we achieved a really high inactivation in all the cases.
Okay, fast.
So you talk about shelf life in terms of bacterial contamination. Do you look at texture of fruit? Because sometimes the high pressure actually collapses cell walls, and that leads to a kind of softening in this texture.
Yeah, I didn't show you all the results because of time problem, but we did the sensor evaluation for all the products during the shelf life, and we never seen a decrease in sensorial acceptance. So in the majority of the cases, the sensorial acceptance was higher in the treated products with respect to the treated one, or it was actually the same.
Okay. Now we have to move on. Thank you
Thank
very
you.
much.
Thank you.
And now I have to find your presentation. It's here. Yeah. So it's here. Okay, so Pietro, the floor is yours. I will interrupt you after 10 minutes.
Yeah, I have time here also. Okay, so good afternoon again to everyone. So we start from the same question that we had during the pitch. Why are organic products often considered old-fashioned ones to produce as in the past? And this happened also during agricultural practices. But in our opinion, they have to be more protected than the conventional one for the motivation that also Ricardo was explaining us before. If we think to preserves of dehydrated fluid, we can have, in the first case, thermal degradation of thermolabile compounds, but also in the second case, we can have safety problem bound, for example, to mycotoxin because sun drying, or on the contrary, to sulfites and other preservatives that are used to avoid this kind of problem. So the main hypothesis of the project is that we have to tailor processing technology considering raw material characteristics, particularly for organic fruit products or fruit and vegetable products in general, because this processing technology have to be strictly designed to the specificity of each kind of commodity through the application, implementation of tailored rules and principles. I mean, too often happen that we have a very good raw materials in terms of nutritional and sensorial properties, but we don't care about processing. But we can do very big mistakes and we can spoil what we have in the raw materials applying conventional or not tailored processing technology. So what we tried to do in the project with specific case study was to apply a new strategy, both in terms of preservation and fortification of the peculiar functional properties of organic raw materials, with the application mainly of non-thermal technology. So the principal aim of the project was to improve the competitiveness of the organic sector, increasing the level of quality, sustainability, and consumer confidence of organic free products, also together with the valorization of byproducts. As I mentioned before, I mean, theoretically, byproducts from organic raw materials have an added value that is higher than the conventional ones because we don't have pesticide and we can use them for several applications, particularly for ingredients preparation. So I was the coordinator of the project and we involved partners that we already knew from a previous core organic project from the University of Bucharest, from Reading University, from Gaziantep University in Turkey, CRIF in Turkey again, and University of Warsaw and VTT in Finland, sorry. And the project had a duration from the 1st of November 2020 to the end of May 2024. And we had a lot of competencies in terms of food processing, particularly from Bologna, Warsaw, and also Turkey, but we have also very important competencies involved from VTT in terms of chemical and nutritional knowledge, but also in terms of consumer study from the University of Reading. So we try to apply mild processing technology in order to obtain and to test innovative products based on organic raw materials. So in order to produce innovative minimal processed fruit and vegetable, I mean, fresh cut fruit and vegetable are just a part of the minimal processed ones, because with some innovative technology, like for example, vacuum impregnation, we can also improve the nutritional and the sensorial quality of these raw materials. And but we also try to obtain innovative snacks with the combination of electroporation technology and also innovative drying techniques. In terms of byproduct valorization, we try to obtain ingredients that have been used to complex product, for example, to do apple impregnation or formulation of innovative bars. Here, just some additional details about processing technology. So we play with pressure, applying vacuum impregnation, but also applying high hydrostatic pressure to do impregnation or very difficult compounds in terms of absorption from porous tissue. We apply edible coating as a protection to specific fresh cut fruit and vegetable, but also we do drying with different techniques. We do ultrasound assisted drying, PEF assisted drying, radio frequency drying, the hydro freezing also, and osmotic dihydration as a preliminary test to a further drying technique. And on all these products, we evaluate the shelf life, the quality. Okay, we intended the shelf life, not just the safety, the microbiological safety that have to be very important, for example, for minimally processed fruit. But for fruit snacks, we have to evaluate texture and other kind of attributes that has to be carefully considered. So these were the specific objective of our project, to create products, to understand for specific products consumer attitudes and preference, but also to evaluate the environmental impact of this innovative technology compared to the conventional one. Also to produce a sort of code of practices to be applied for the processing of raw materials from the organic sector. Just some example of the product that we got. Of course, apple is a very suitable product for vacuum impregnation because we have the 30% of empty space in the structure. So apple can be very, very suitable, for example, to be impregnated with functional solution like with, I don't know, green tea extracts or beta-glucans, but also yakonjui. So we can fortify from a nutritional point of view using organic ingredient porous structure of specific fruit and vegetable, apples, but also aubergine and other kind of raw materials. And here we can see that we can improve the polyphenol content of apples of 5 and 6 times just applying vacuum impregnation with a specific functional solution. Another strategy to obtain better product in terms of quality and sensorial properties is drying. So if we apply, for example, radio frequency dry, we can decrease a lot the performance and increase the performance and decrease a lot the temperature and the time for drying. So this means that we maintain a better nutritional quality in terms of thermal abide compounds, but also a better color and better sensorial properties. We also try to compare freeze drying with innovative drying technology, and we got very interesting results. Other example of the snacks that we perform, in this case, we applied vacuum impregnation before drying. So you can have, for example, an apple snack with live probiotics. So we can create new functional product using organic ingredients and innovative non-thermal technology. In terms of LCA, I mean, it can seem that we are applying too much processing. You know, in this historical period, also in the wrong way, in my opinion, we are speaking a lot of ultra processing. But if we compare, for example, a conventional drying or a PEF assisted drying to obtain specific apple snacks, we can see that we can save a lot of energy during drying. So we apply a further processing step before drying, but finally, if we consider, for example, the global warming indicators, that is one important indicator in LCA approach, we can see that we have an important decrease of this impact. So finally, which are the next steps that we would like to have in the prosecution of our activity. First of all, the interaction with policymakers for a better management of processing for organic production. We know, I mean, in Europe, we have a very virtuous, let me say, regulation about organic production. But in our opinion, processing is still something that is not so well considered. We have some indication about some processing that we cannot apply for organic product, but the important thing is to have a protection of specific processing that can be virtuous to maintain and to increase the sensorial and nutritional quality of the raw materials. The second important step that we would like to try to have in our future is, of course, to have new possibility for this research, but also with the involvement of extra UE countries. Now we have a very interesting project with Colombia, where they are trying to develop a specific regulation on organic in order to import in Europe, to export in Europe their raw materials. And this is very important. I mean, we have to create an international network in order to improve this sector. Finally, we have to understand something more about what happened when we process the materials from organic sector and we get this kind of products. So we have to, in our opinion, we don't have to speak anymore of farm to fork approach, but we have to speak of farm to gut to understand what happened as a consequence of the consumption of this kind of product during our digestion. And thank you very much for the attention. And Frank, are you happy all the time?
Yes, thank you very much. Time. But we don't have so much time for questions. But one short one, probably this one. Okay. Enough that we don't have time. So let's maybe try to get the online presentation also, because we also have to end a few minutes before 6. So we have 10 minutes for the online presentation, and then we would be perfect in time. Ariana, can you hear us? Are you there?
Yes, here I am.
Perfect, perfect. I can show your presentation.
Okay, I can.
You can. Yes. You can just tell me when I have to go to the next slide.
Okay, thank you.
10 minutes. If you could stick to the 10 minutes, that would be perfect.
I will try to be fast as possible. Good evening to all the people in the room, in the Berlin room. I'm Arianna, and I'm representative of the Me Wine Project Consortium. So I'm going to briefly present this innovative treatment for the stabilization of the wine. Next. So the project moves from an assumption, which is that the wine market is gaining increasing relevance globally. And this means a large volume of wine is transported, is stored for long-time storage, and can be potentially exposed to harmful conditions. For example, temperature fluctuation. And this extreme condition can affect the sensory characteristic and the physicochemical stability of wine. So it is quite important for wine producer to obtain stable wine at bottling. And among the several factors involved in instability, there is the protein instability, which is particularly important for the white wines. And this is caused by the presence, the persistence of small proteins in wine that under extreme temperature conditions can undergo denaturation. So they can be less soluble and develop turbidity or formation of deposit. So the current strategies to prevent this instability is preventive strategies. So some clarifying agents are used in the wine supply chain to remove the proteins and so to prevent the instability in bottled wine. But this approach is largely used, but also suffer of several disadvantages that have an impact also in the overall sustainability of the wine chain. Next. So When we think about an industrial process, we need to consider the key pillars for its sustainability. That means its economic impact, so the efficiency of the process and also the cost effectiveness of the process, the environmental impact in terms of waste, the amount and the nature of waste that is produced, and also the social impact, so the connection between the process, the product, and the perception of quality by the consumers. So we can overcome the limitation of traditional conventional approaches by introducing innovative and circular approaches. So we can boost a sustainable enological chain. Next. So there are two key aspects which were considered in the MIWINE project. The first, the introduction of an innovative solvent material, which has some particular properties. Obviously, it has to be food grade. Obviously, it has to be selective for the removal of protein, but also it has to be robust enough to withstand the mechanical stress induced by a continuous process. In fact, most of the traditional processes are performed in batch, and this is one of the main issues related to their sustainability. So the second aspect is the introduction of this innovative sorbent into a flow system device, which operates under continuous flow. Next. So the first step was obviously the introduction of this innovative material, the design, the engineering, and the optimization. The ceramic material were considered because they are usually food grade and because they are easy to engineer at the different dimension levels. So between all the ceramic material assayed, the titanium dioxide in nanometric dimension was considered the most promising. So it was used to prepare a composite material composed by an inert glass sphere with a deposition of a thin layer of titanium dioxide, which was deposited by salt gel process, sintered to high temperature, to have a thin layer of sorbent, few micrometers, with a mesoporous structure, which greatly enhance the surface area in contact with the wine. Next. So the preliminary result demonstrated a clear advantage of the innovative sorbent compared to the conventional material, which is the bentonite. In fact, it can be used in a flow system. It's robust enough to withstand the flow process. It can reduce the time for the processing and limit the production of byproducts, so enhance the yield of the process. It can be regenerated and recycled after usage, and these are the most important points. After a release of titanium dioxide in wine and in model wine was considered to assess the safety, and all the tests showed the concentration of titanium dioxide in the range of part per billions, so some concentration that can be considered acceptable according to the current regulation. Next. So the laboratory scale flow device consisted of few elements, and they are food grade and certified for the contact with alcoholic beverages. The wine was supplied to a recirculating system by a peristaltic pump, and the material was hauled into a column to enable the contact with the wine during the process. So in order to optimize the process, some performance indicators were selected, and you can see here include the amount of sorbent per volume of wine, the time of contact, the flow rate, and also the maximum protein absorption capacity was evaluated using some theoretical model, Langmuir isotherm in more detail. The next. So after the wines that were treated with the innovative method were assessed for their physical chemical parameters, First of all, obviously, the protein stability, but also other quality parameters. And also, a sensory evaluation was performed, both in terms of description and in terms of comparison with the control. The control was the same wine treated with the conventional method, the bentonite in batch. Next. So, the project outcomes, in our opinion, were well aligned with the initial and main objective of the MiWine project. In fact, we were able to introduce an innovative material potentially suited for industrial transfer. And this was considered also taking into account the economic feasibility. So the laboratory scale costs were compared with an estimate of a cost in the case of transfer at the industrial scale, and also both the evaluation were compared with the cost of the traditional method, considering the overall process. After also the laboratory scale plant was developed, was engineered, and was optimized for the optimum process parameter. Next. So we found that the MiWine outcomes satisfied that sustainability pillars that we introduced before, and the economic impact was improved because the process was made more efficient and faster, so more economic. The environmental impact was improved, considering that the characteristic of the process make it less susceptible to the production of waste, and also introduce material that can be reused. Also, when we made comparison with the traditional conventional process for wine stabilization, we considered that the quality of the wine was the same, was comparable with the conventional approach. Next. So, there are some steps forward to be considered to achieve the industrial transfer of this laboratory scale technology. So this includes the scaling up of both the material and the device engineering to satisfy the volume and the characteristic of an industrial process. Obviously, another key point is to certify the sorbent material for food contact according to the current regulation. Next. Just finally, I'm going to introduce the consortium. The MiWine project advantaged for the cooperation of an interdisciplinary consortium, which involved different expertise that were put together with a common goal to improve the sustainability of the wine chain. And next, and final, I would like to thank you for your attention. I hope I was fast enough, and I leave the contact of the coordinator and of me presenting this project. And I'm available for any question.
Yes, thank you very much. So we have 5 minutes until 6, and I think we should finish at least until 6. So if we have some questions, we can ask them now. Are there any questions from the audience or online or anybody? Okay, if there are no questions, then I think everything was very clear, or people are very tired by now because it was a very long day.
Maybe the second.
Yeah, maybe everybody needs a second. Yes, so, okay, but let me take the opportunity to say thank you very much to all the presenters and to all the people attending, and to everybody who was here and online. I think it was a long day, but we heard a lot of interesting things about the projects, and I hope that some new projects also come out of this networking opportunity here as well. So I think we will end it here because all the other people will soon come in back in this room here to have the final wrap up, and then afterwards there will be dinner as well. So thank you very much, everybody.